Cambridge International AS and A-Level Mathematics, Code 9709, 2020 Specimen Paper 1, Pure Mathematics 1. The link to the question paper is in the description below. Hi, I am Babak Majidzadeh Garjani. In this video, I'm going to solve the first problem of this sample paper. Let me read the question for you first. The following points, A, B, C, D, and E, with given coordinates of course, lie on the curve y equals to f of x. The table below shows the gradients of the chords AE and BE. Chord AE, gradient of chord 4. Chord BE, gradient of chord 3. Part A. Complete the table to show the gradients of CE and DE. Okay. To tackle the first part of the problem, let me just remind you of a very simple formula that I am completely sure every one of you knows about that, but it is good just to remind it. Okay, assume that I have a straight line, which I call it L, and now assume that 2 points M and N lies on this line, and the coordinates of these points are given to me. The coordinates of M are x sub m and y sub m, and the coordinates of N are x sub n and y sub n. If I want to calculate the gradient of this line, say m sub l, the gradient of a straight line L, this is equal to delta y, the change in y values, divided by delta x, the change in x values. Of course, delta y can be written in this form, yn minus ym divided by xn minus xm. Of course, you can also write ym minus yn divided by xm minus xn. It doesn't matter which order you choose, but whatever you choose for the numerator, you have to respect that order for the denominator as well. So you see that in the first fraction, I wrote yn minus ym, and I wrote xn minus xm in the denominator. For the second fraction, I wrote m first and n second for the numerator, and I respected the same order for the denominator. Okay, now let us go and start solving this problem. Part A of this problem, I am supposed to calculate the gradient of chord CE. So let me denote it by m sub CE. This becomes ye minus yc divided by xe minus xc. But you can see that ye is 9 and yc is 7.75. In the denominator, xe is 2 and xc is 1.5. Okay, 9 minus 7.75 is 1.25 divided by 2 minus 1.5 is 0.5. For me, it's easier to multiply the numerator and the denominator by 10. If I do that, the numerator becomes 12.5 and the denominator becomes 5. And now it is easy to see that 12.5 divided by 5 is 2.5. Okay, so the gradient of the chord CE is equal to 2.5. Yes, so this is one thing that we got here. And if you want, you can also write it here in this empty box, 2.5. Okay, now similarly, I go and calculate the gradient of chord DE. So let me denote it as usual, m sub DE. It's equal to ye minus yd divided by xc minus xd. And ye is 9 as before, but yd, you can immediately see it's 8.79 divided by xc is, oh, I made a mistake here, sorry. This is not xc, this is xe. Okay, sorry. And then xe is 2, xd is 1.9. Yes. Now, the numerator, 9 minus 8.79 is 0.21, and the denominator, 2 minus 1.9 is 0.1. And again, I rescale it by a factor of 10, so it becomes 2.1 in the numerator and just simply 1 in the denominator, which gives me 2.1. So this means that we calculated the gradient of chord DE to be 2.1. Yes? Okay, and again, if you want, we can also write it here. Okay, so far so good. Now we go to the second part of this problem. Let us read it. State what the values in the table indicate about the value of f prime of 2, the derivative of function f at x equal to 2. Okay? So, to motivate you about how to answer this question, I would say I would write like this. I think it's better to draw a figure, but of course this figure might be far away from what the real graph is, because I don't have enough information to be able to draw the graph in full details. But let me, just for illuminating purposes, let me just assume that this is the graph of my function. And let me assume that, for example, this is A and this is B. Of course, I am a little bit exaggerating for the distances between the points, okay? But then it would be easier for me to draw a better picture. So assume that this is point A, B, C, and D, and then you have finally your point E, okay? So the chord AE is this chord, if I can draw it, yes. And then the gradient of this chord is 4 according to the table, yes. And then chord BE is this chord, and the gradient according to the table above is 3. And we calculated the gradient of chord CE, and we got 2.5 for this chord. And finally, for chord DE, we found 2.1. Yes. So we already see that these red chords, the gradients are 4, 3, 2.5, and 2.1. Might be you get this feeling that these numbers are approaching to number 2. Okay, this is on the one hand. On the other hand, what is the geometric interpretation for derivative? The derivative is the gradient of the tangent line at the x-coordinate of the point of tangency. So for example, here in this graph, if I draw the tangent line to the graph of this function at point E, I will try to do it by this green line. Yes. What you know about the gradient of this green line is that this green line, the gradient of this green line is f prime of 2. Why? Because the x-coordinate of point, if the x-coordinate of point E is 2, so when you write f prime of 2, that is the gradient of the tangent line. So the gradient of the tangent line at E is equal to f prime of 2. This is on the one hand. On the other hand, you might get this feeling that the gradients of these chords are approaching to a number 2, to the number 2. So then I would say that answering to part B would be like that. State what the values in the table indicate about the value of f prime of 2. I would say that they indicate that f prime 2 is equal to